The year was 1977. While the world turned its eyes to disco balls, space shuttles, and Cold War tensions, something much quieter, much more profound, was slipping through the veil of our solar system. Voyager 2, a spacecraft built by NASA, left Earth with little more than a 5-year assignment to visit the outer planets and then drift into obscurity. But Voyager had no intention of fading quietly. What it found decades later, beyond the known boundaries of our solar system, would shake scientists to their core. The shock wasn't in what it encountered. It was in what had been missed, ignored, or misunderstood for years. Something had been speaking from the void all along, and almost no one was listening. Voyager 2 was never meant to go this far. NASA engineers had planned for a limited mission, a quick tour past Jupiter, Saturn, and, if all went well, Uranus and Neptune. With a bit of luck, it might survive long enough to send back a handful of photos and readings before its systems died. But Voyager 2 and its twin Voyager 1 defied every limit placed upon them. Through solar winds, radiation storms, and temperatures so cold they could freeze oxygen solid, the spacecraft endured, pushed on by a small nuclear power source and an engineering miracle. By the 2010s, Voyager 2 was more than 11 billion miles from Earth. Its systems were old, faltering, and kept alive through clever engineering tweaks back at NASA's Jet Propulsion Laboratory. Still, it transmitted. Still, it endured. And then came the moment scientists had waited decades for. Voyager 2 reached the edge of the heliosphere, the vast bubble carved out by the sun's solar wind, and crossed into interstellar space. But this moment, as historic as it was, didn't make the headlines it deserved. What everyone seemed to overlook in the fanfare of the crossing was the data, the whisper from deep space that began flowing in as soon as Voyager passed into the unknown. That whisper turned into a message that, once understood, would force NASA to reevaluate not just the structure of our solar system, but the very nature of the space surrounding it. One of the first signs that something extraordinary was happening came from the spacecraft's plasma wave instrument. For decades, scientists assumed that the sun's influence gradually faded into the black of interstellar space. They expected a transitional zone, blurry, soft, stretched. But Voyager 2 recorded something else entirely. An abrupt, nearly instantaneous change in environment. The density of plasma around the spacecraft spiked, temperatures jumped, and most tellingly, galactic cosmic rays, high-energy particles from beyond our solar system, surged by nearly 70%. It was as if the spacecraft had passed through an invisible gate. That gate, now known as the heliopause, was supposed to be a theoretical boundary. Voyager 2 made it real, and its abruptness left scientists stunned. This wasn't a slow fade. This was a wall, one that protected the planet's inside from lethal radiation, a force field created by the sun itself. And Voyager 2 had punched through it. But even more baffling was the magnetic field data. Voyager 2 carried instruments that tracked the sun's magnetic field, long understood to spiral outward with the solar wind. As the spacecraft exited the heliosphere, scientists expected chaos, a tangle of magnetic orientations as the solar field collapsed into interstellar turbulence. Instead, they got precision. The magnetic field on the other side of the heliopause wasn't turbulent, it was aligned, almost eerily so. The magnetic field from the sun matched the interstellar field in direction, as though the two were in conversation across cosmic distance. This alignment made no sense. Existing models had predicted a misalignment of at least 20 to 30 degrees, a clear demarcation between us and them. But the field transition was smooth, nearly seamless. It raised a simple but disturbing question: why? Was this evidence of a larger, ordered structure in the interstellar medium? Was our solar system cradled within a carefully layered galactic fabric we never understood? And if so, what did that mean for everything else we thought we knew about space? There was more. As Voyager 2 continued to drift beyond the heliopause, the instruments picked up what can only be described as interstellar weather. Scientists had expected monotony, constant radiation levels, unchanging plasma density, uniform space. But what Voyager found was anything but uniform. Radiation levels fluctuated. Plasma density spiked and dropped. Magnetic fields twisted and realigned. Something dynamic was unfolding beyond the boundary, like weather patterns in an ocean we had never sailed before. These fluctuations hinted at the presence of structures, layers, zones, or even waves traveling through the interstellar medium. Some may have been the echoes of long-dead supernovae, others might be remnants of ancient star systems. But they were there, undeniable and alive in the data. And here's where things began to get strange. Because Voyager 1, which had crossed into interstellar space 6 years earlier, told a different story. It too had passed the heliopause, but it crossed at 119 astronomical units from the Sun, while Voyager 2 did so at 121 astronomical units. The difference wasn't just distance, it was behavior. Voyager 1 lacked a working plasma instrument, so its data on plasma density was inferred, not directly measured. Voyager 2, fully functional in that regard, offered hard proof. And that proof showed that even the boundary itself, the very edge of our solar system, wasn't a fixed shell. It shifted, bent, and fluctuated with the sun's cycles and galactic pressure. This dynamic nature of the heliosphere challenged everything. It wasn't a bubble. It was more like a comet tail, stretched, distorted, responsive. Solar flares, interstellar pressure waves, and cosmic dust flows all had the power to change its shape. Voyager 2's crossing wasn't just a milestone. It was a revelation that the solar system breathes in and out against the galaxy's lungs. But perhaps the most haunting aspect of Voyager 2's journey was this. Most of its discoveries had been buried in years of overlooked transmissions. The data wasn't hidden. It was public, available, flowing from the spacecraft like clockwork. But in the absence of spectacular photos or dramatic announcements, few had paid attention. It was only after teams began digging deep, correlating magnetic readings, plasma changes, and radiation data, that the true magnitude of what Voyager had seen came into focus. For years, everyone had looked to the stars, waiting for a message from the unknown. What they didn't realize was that the message had already arrived. Not from alien civilizations, not from distant worlds, but from the edge of our own front yard, from a spacecraft built in the 1970s that simply refused to die. By the time Voyager 2 had drifted far beyond the sun's protective shell, it had already exposed one of the greatest misconceptions in modern astrophysics. That space, once free of solar influence, would be simple, quiet, and dead. But in reality, interstellar space was not silent. It was humming. And Voyager 2 was listening. The signals it sent back were faint, low-frequency plasma oscillations, vibrations in the interstellar medium that hinted at a cosmic ocean more alive than anyone had anticipated. Yet again, these whispers went mostly unnoticed by the world at large, lost beneath headlines about newer missions and flashier space telescopes. But inside NASA's Deep Space Network, where engineers monitored every blip from the aging spacecraft, the message was deafening. One of the most astonishing discoveries came in the form of pressure waves, shock-like pulses moving through the plasma beyond the heliopause. These weren't random. They had structure, they had rhythm, and more importantly, they had origin. The waves, as scientists discovered, were likely caused by solar activity, massive solar eruptions like coronal mass ejections, CMEs, that blasted through the solar system, reached the heliopause, and sent ripples into interstellar space. Voyager 2 was able to detect the echo of those events months, even years after they occurred. It was a cosmic feedback loop, a delayed conversation between the sun and the galaxy. This proved something almost too vast to comprehend. Our star, small as it is on a galactic scale, still leaves its fingerprint well into interstellar territory. The solar system, it turns out, doesn't just end. It spills outward, blends, and interacts. We're not separated from the galaxy. We're woven into it. But for all the measurable phenomena, radiation levels, plasma densities, shock waves, there were also the anomalies, glitches in the data, brief electromagnetic spikes that didn't match any known source, occasional distortions that had no clear correlation to instrument malfunction. In 2019, Voyager 2 experienced what appeared to be a brief system blackout. For a few tense hours, its instruments went silent. And then, just as suddenly, they came back online. NASA attributed the event to an unexpected drain on its power systems. Understandable, given that the craft had been flying blind for over 40 years. But not everyone was convinced. Among the scientific community, there were whispers, never published but certainly discussed in hushed tones, about the possibility of interstellar environmental interference. Something out there, perhaps magnetic turbulence or energetic particle streams, had temporarily disabled the probe. The explanation seemed plausible, yet incomplete. Voyager 2 had weathered worse before. Why then, in the quiet vastness of interstellar space, would it falter now? It wasn't just the blackout. Over the years, both Voyager 1 and 2 had recorded brief anomalies, unexpected frequency shifts, momentary telemetry dropouts, even uncommanded changes in system behavior. Each was individually dismissed as hardware aging, but taken together, they painted a more puzzling picture. Some scientists began to question whether the interstellar medium itself was playing tricks, interfering with electromagnetic signals in ways we didn't yet understand. Others, more speculative, wondered aloud if something else was present out there, something we had not yet mapped, not yet modeled. There were even those who revisited the old debate over the golden record, the audio-visual time capsule bolted onto the side of each Voyager spacecraft. On that record were greetings in dozens of languages, images of Earth, and a map, an actual map, showing the location of our solar system in relation to nearby pulsars. It was intended as a message of peace to any intelligent life that might one day find the probe. But it also meant, quite literally, that we'd placed a beacon in the dark, pointing right back to our home. What if something had noticed? Of course, mainstream scientists were quick to reject such notions. The distances involved were too vast, the signals too weak. Interstellar space is not a highway, it's an ocean, and Voyager 2 is a message in a bottle, adrift, alone, and most likely unseen. But even within the realm of accepted science, the very idea that we could influence or detect something beyond the heliopause was thrilling. It raised serious questions about the design of future probes. Should they continue to broadcast? Should they listen instead? Should they carry messages at all? Meanwhile, the discoveries continued to pour in. One of the most profound differences between Voyager 1 and Voyager 2 was the state of their instruments at the moment of heliopause crossing. Voyager 1's plasma detector had failed, forcing scientists to infer plasma density from oscillations in the magnetic field. But Voyager 2's detector was fully operational, and it gave scientists their first direct measurement of interstellar plasma. The numbers were shocking, nearly 40 times denser than the plasma inside the heliosphere. That sharp increase confirmed that the heliopause wasn't just a magnetic transition. It was a boundary of matter, a density wall, a shift in the very nature of space itself. And yet Voyager 1 and Voyager 2 didn't agree on everything. Their temperature readings, for instance, were inconsistent. While Voyager 2 observed a noticeable temperature spike during its crossing, Voyager 1's data suggested a cooler transition. This discrepancy led scientists to an inevitable conclusion. The heliosphere is not a symmetrical bubble. It's not a neat sphere with the sun at the center. Instead, it's more like a windsock or a comet tail, bulging in some places, compressed in others. Its shape is sculpted by solar cycles, galactic pressures, and magnetic tides we're only beginning to understand. The interstellar medium itself, once thought to be homogeneous, was revealing its own chaotic beauty. Voyager 2's continued transmissions revealed gradients, shifting zones of particle density, magnetic turbulence, and cosmic ray variation. This was a map of something ancient and ever-changing, a fossil record of the galaxy's hidden forces. And thanks to one aging probe, we now had a key to read it. Despite its dwindling power reserves, Voyager 2 kept going. Each signal it sent back had to travel more than 18 billion kilometers, taking over 16 hours to reach Earth. And yet it came, delivered in packets of data, slower than a dial-up connection, but more valuable than gold. Scientists at NASA knew that each transmission could be the last. But still, the spacecraft whispered. The stunning part wasn't just what Voyager 2 had discovered. It was the realization that much of it had been there all along, buried in telemetry logs and low-frequency waveforms, dismissed, shelved, or simply misunderstood. Only after revisiting the data with new eyes did the truth begin to emerge. The universe wasn't a void. It was structured, layered, alive with forces far greater and older than anything born under our sun. And Voyager 2 had touched it. The silence that lay beyond Voyager 2 was not empty. It was watchful. The deeper it drifted into the galactic unknown, the more its instruments began to pick up strange rhythms. These weren't simply random spikes in radiation or harmless noise. They were patterns, subtle modulations in the electromagnetic environment, slow pulses in the plasma density, and deviations in the interstellar magnetic field that seemed to repeat over irregular intervals. At first, NASA analysts dismissed them as background variations, statistical noise, but after cross-referencing with historical solar activity and comparing them to similar hints in Voyager 1's ancient data logs, something became unmistakably clear. Interstellar space was not uniform. It was patterned, and Voyager 2 was navigating a mosaic of invisible zones, regions of altered radiation pressure and magnetic alignment. This wasn't just science fiction. It was the dawning of a new frontier of heliophysics. The heliosphere, the invisible shield around our solar system, was behaving like a living membrane. And every probe, every echo, every ripple was showing us that our solar system wasn't simply floating in the void. It was moving through something vast and alive, with properties shaped by eons of supernova explosions, galactic magnetic currents, and clouds of ancient dust. Every detail Voyager 2 transmitted forced astrophysicists to reevaluate what space even means. There was also a new urgency. As the spacecraft's power dwindled, NASA began turning off non-essential systems one by one, shutting down heaters, backup components, and scientific instruments. Each power-saving decision came with a heavy cost. Less data, fewer observations, one more blind spot. It was like dimming the lights in a cathedral, just as the sacred scriptures were being revealed. And yet, even on the brink of silence, Voyager 2 was delivering insights nobody had expected. In one particularly striking data transmission, researchers observed a sudden shift in magnetic field orientation without a corresponding increase in particle energy. This defied known models of how the interstellar medium should behave. Magnetic turbulence should have caused heating, motion, excitation. But instead, it looked like the magnetic field had simply twisted, quietly like the movement of a cosmic hinge. No shockwave, no warning, just a directional flip, as though the spacecraft had crossed into a subtly different sector of space. This begged the question, was the interstellar medium compartmentalized? Were there galactic zones with their own microclimates, magnetically bounded regions floating in the cosmic sea? If true, this would mean that our solar system itself might be passing through such a region. Earth's distant past could have been shaped by the properties of the interstellar zone we inhabited at the time. Cosmic ray intensity influencing climate cycles, magnetic alignment affecting cloud formation, even subtle pressure variations impacting solar output. Voyager 2 had become not just an explorer of space, but an archaeologist of the galactic environment. Still, it wasn't just the scientific community that was watching. As news slowly leaked into public forums and independent researchers got their hands on raw data dumps, alternative theorists began to speculate. They combed through the telemetry, pointing to irregular bursts in radio frequency emissions and citing what they claimed were unnatural signal patterns. Some claimed the probe had passed through an artificial boundary. Others suggested it had encountered something more exotic, a structure perhaps, a signal source, even a presence. These theories were never validated by NASA, of course, but the underlying fascination could not be denied. Voyager 2 had entered a place where no human artifact had ever been, and it was not coming back. One incident, buried in internal memos and rarely discussed outside classified circles, involved a series of unexpected signal fluctuations observed in 2023. Over a 3-week span, the frequency drifted more than it ever had before, while the bit stream showed repetitive telemetry dropouts and checksum failures. Engineers blamed a failing oscillator and solar wind interference, but a small team within JPL noted that the pattern in the dropouts resembled a waveform, one that repeated every 17.4 hours with eerie precision. A review was ordered. The pattern was eventually dismissed as coincidence. But for those who studied the file in detail, it raised a tantalizing question. Was it a malfunction or a message? Even if never confirmed, the impact of Voyager 2's journey was undeniable. It had changed our conception of space, altered our theories of solar protection, and given us a cosmic vantage point few had dreamed possible. The heliosphere, once thought of as a passive boundary, now appeared as a kind of magnetic shell, dynamic, pulsing, and responsive to galactic winds. Its movement and shape shifted over time, like a jellyfish drifting through a dark sea of stars. Understanding this behavior wasn't just academic. It was vital for the future of space exploration. Any mission that hoped to venture beyond Pluto into true deep space would need to understand the nature of interstellar weather, the risks of particle radiation, and the shielding potential of a healthy heliosphere. And then came the sobering reality. Voyager 2's clock was ticking. Its radioisotope thermoelectric generators, the plutonium-powered hearts that had kept it alive since 1977, were fading fast. Every watt mattered now. By late 2025, most scientists agreed the spacecraft would likely fall silent forever. The final transmission, when it came, might just be a soft hiss of background noise, an epilogue to one of humanity's greatest voyages. And then, nothing. No return, no recovery. But Voyager 2 will not die in vain. It will continue drifting through interstellar space for billions of years, a silent emissary of Earth. Long after our cities have crumbled, our satellites burned up in re-entry, and even our species perhaps vanished, Voyager 2 will still be there, cold, intact, and still bearing the golden record that tells the story of who we were. A phonograph in the void, waiting. Its discoveries are etched not just in scientific papers, but in the very foundation of our understanding of the cosmos. Voyager 2 showed us that our solar system is protected, but not isolated. That space is not a desert, but a frontier of invisible tides and alien pressures. That we are part of something larger, more dynamic, more alive than we ever dared to imagine. And in the end, perhaps that's the real gift Voyager 2 has given us. Not just data, not just readings, but perspective. A glimpse of how small we are, how far we can reach, and how much is still waiting out there in the dark. NASA was stunned, not by a single transmission, but by the totality of it, by what they almost missed, by what the world nearly ignored. Because Voyager 2 didn't just explore the edge of space, it changed it.